Dumelang, I just want to do a quick revision on exponents before we get to more questions. And it'll be about distributing exponents, that is multiplying exponents across multiplication and division. When we have a power raised to an exponent, for instance, if we have a base inside the bracket raised to an exponent, all you have to do is to multiply the exponents. So you will multiply the exponent that is inside the bracket with the exponent that is outside the bracket. You will multiply this 2 multiplied with that 3. 2 times 3 will give you 3 to the exponent of 6. Now, what happens when we are given 2 or more factors like this here? The principle doesn't change. You can multiply exponents across multiplication and division. Basically, I will still take this 2, multiply it with that 3, then take the 3, multiply it with the 5. And you will end up having 3 to the exponent of 2 times 3 times 2 to the exponent of 5 times 3. 2 times 3 will give me 6, so I'll have 3 to the exponent of 6. And 2 times, well, 2 raised to the exponent of 5 times 3. 5 times 3 is 15. I'll end up having 2 raised to the exponent of 15. Now, when we are given 2 or more factors with unknown bases, like here we have x, which is an unknown base, what happens? And we only have 5 there. Please know that we have 2 bases inside the bracket. That 5 has an exponent, and the exponent of that 5 is 1. Even though it's not written, it's there. We're going to take that 1, times it by 3, and take the 4, times it by 3 too. Now you will have 5 to the exponent of 1 times 3 and x to the exponent of 4 times 3. 1 times 3 is 3 and 4 times 3 is 12. Okay. What if we have this? 5 and y have an exponent of 1, even though we didn't write it. Then you're going to take this 1, times it by 3, take this 1, times it by 3, take the 4, times it by 3. All 3 exponents will be multiplied by the outside exponent. This will give you 5 to the exponent of 1 times 3, y to the exponent of 1 times 3, x to the exponent of 4 times 3, which will give you 5 to the exponent of 3 times y to the exponent of 3 times x to the exponent of 12. But y to the exponent, 5 to the exponent of 3 is 125. That's why I end up having 125 y cubed x to the exponent of 12. What if we have something like this, where we are dividing factors? I've got a base of 3 in the numerator, and I've got a base of 2 in the denominator. I cannot apply the exponential law of division because the bases are not the same. But both the numerator and the denominator are raised to the exponent of 5. So I'm going to multiply the 2 in the numerator with the 5 outside. And take the same 5 multiplied with the 5 in the denominator. So you just multiply the exponent. This multiplied by that. This, you will multiply it by that. In the numerator, I'll end up having 2 times 5. How much is 2 times 5? 2 times 5 will give me 10. And in the denominator, I'll have 2 to the exponent of 5 times 5, which will give me 25. Now you'll end up having 3 to the exponent of 10 divided by 2 to the exponent of 25. You can't simplify those two. Just leave them as they are. Now, what happens when you're distributing vectors with variables that are divided like this? Now, you will notice that the 2 in the denominator doesn't have the exponent. Please note that the exponent will be 1. So you multiply all the exponents like normal. You will have 2 times 5, 3 times 5, 1 times 5, and 2 times 5. That will give us 3 to the exponent of 2 times 5 multiplied by y to the exponent of 3 times 5. In the denominator, we'll have 2 to the exponent of 1 times 5 times x to the exponent of 2 times 5. Now, the exponent of 3 will be 10. The exponent of y will be 15. And the exponent of 2 in the denominator will be 5. And the exponent of x in the denominator will be 10. All right. That is just revision of how we multiply or we distribute exponents. More to follow. Please like, subscribe, share on all your social media platforms. Thank you for watching. Hoto.